There we go. It's going up. Good morning. We'll be starting the seminar at approximately 2 minutes past the top of the hour. Thank you. Good morning or good afternoon, and welcome to Secured Distributed C4I, moving at the speed of the mission. My name is Rob Chevlot, and VP of Sales for the Central Region for PESA, and we are excited to have you with us today, and we very much appreciate your time. A few notes or housekeeping issues before we start today. First, all important contact information regarding how to reach us if you should have any questions is on the right-hand side of the screen. Second, today's presentation is being recorded, and a link will be provided to all attendees in a couple days after the seminar. Last but not least, there will be a Q&A session at the end of the presentation, and please submit your questions or thoughts in the Q&A dialogue at any time. Panelists are on hand to answer some of your questions as they come in, or others will wait until the end, and any questions that we do not get to, we'll make sure we follow up after the presentation. Today's presenters will be Robert Welch, Technical Solutions Leads for Arista, Scott Barella, CTO PESA, and additional panelists will be Scott Wilson, Director of Sales for Arista Federal Division, Jason Walker, Systems Engineering Manager, Federal Division for Arista, and myself, Rob Chevlot. I'll also be acting as moderator and assisting with the Q&A information. Again, contact information is shown and will be shown again at the end. So let's get started. Make note to the quote at the top, there's nothing more important than the mission. This is critical, and this is going to be the theme throughout the presentation we're going to be given today. The mission is the utmost important for our customers. And because of that, secure distributed command and control for video for clear and accurate situational awareness is essential. And you're going to hear a lot about situational awareness as we go through this presentation. In other words, we want our solution and experience for our customer to be as good as being there. Advancing to the next slide. So mission requires situational awareness and data-driven information. We take it seriously because guess what? You, our customers, take it seriously. So when we talk about mission, what are some objectives and solution effectiveness? Again, we mentioned the C4I, command, control, computers, communications and intelligence, distributed and immersive. The need for accurate decisions at the speed of the mission. Today's missions require a much higher degree of information and quality of information in order to make accurate, timely, real-time decisions. Adaptive response to changing conditions, informations, and insights are also required. So how do we adapt to increase efficiency and effectiveness in today's new environment? Resilience, we've listed some bullet points here. Resilience, continuity, command and control center collaboration, either collaboration within a controlled environment or collaboration from controlled environments to controlled environments or controlled environments to multiple controlled environments. Removing communication silos and dependencies. In other words, breaking down those silos so clear communications can be received across boundaries. Where today there are silos, what we're going to talk about today, we remove those silos and barriers. Extending higher decision-making capabilities. Today more than ever, the need for accurate, reliable, concise, quality information is critical, including in a secured manner and method. We're going to be talking about that today. And last, a high resolution video makes a difference. We're going to be talking about the need for higher resolution up to 4K video quality that, again, today is becoming much more essential. So that just kind of gives you kind of a backdrop and an overlay of what we're going to be talking about today. We're going to be talking about old technology, current technology, and what primarily we're going to be talking about today is what the new dynamics are going forward. So without further ado, I'm going to turn it over to Agent Welch of Arista. Take it away, Agent Welch.
Thanks, Agent Rob. Appreciate that. You know, what's funny is as we're working through this is, and this is kind of an old adage, is there's nothing more constant than change. And we live in an ever-changing environment. But the other interesting thing is information is key. Information to make the decisions, to know what's going on now, to make those decisions in the future, you know, expect certain things to happen. So we're going to talk about, and this is going to be a little fun, and we encourage you to have a little fun with this topic because it can be a little dry. It's going to get very techie, so warning, techie ahead. So we're going to talk about the old way of doing things versus the new hotness. So you might see a little fun that we have between Scott and myself. We'll talk about the new hotness, but it does remind me of Men in Black and talking about going to the new cool and new hotness here. So Scott, welcome and happy Thursday to you.
Thanks, Robert. Yeah, exactly. You're making fun of my dad's car, so come on now. Absolutely. So we wanted to take some time here to tell you that it takes two to tango, right? And the idea here is that there's no way that we can bring a solution to the table without a partner like Arista. And the idea here is that we can create, you know, very secure signal flows, but it takes a network with the agility and speed and the ability to take on the kinds of flows that we expect in video to be moved around. And with that comes a tightly integrated software-defined network. We also have to have some efficiency and effectiveness across that network. And it really ties us both together in presenting these kinds of solutions. So
well, Scott, talk about. Wait, hang on. Go back to that slide because I think there's a nuance there, and this is really key in why we're doing this together. It's a solution, right? I mean, it's not piece parts. We really put a lot of thought, years of engineering talent into this. putting the teams together to build a solution set. So it's not like it's a bunch of Legos that you build on your own. And we're going to touch upon this more, and didn't mean to interrupt you here, but this is truly an end-to-end solution. But having said that, it's also true end-to-end security. So thinking about all the principles from what you need to do to achieve the mission has already been thought out. So we don't want you to have to think about a bunch of Legos that you have to, put together. We want you to think about this as a fully fledged solution. And that's why we're partnering here. And I think, Scott, do you agree with that?
Yeah, absolutely. It takes the skill sets of both of us. Our past, our credo is kind of with the video has been for 50 odd years, and Arista has that in the networking side of things. So to start with, we are in a number of DoD installations and federal agencies, both intelligence and in government. But these are very traditional baseband infrastructures. They're very isolated, so that a traditional SCIF might be thought of as a kind of concrete bunker, if you will, where we put all the stuff in it. We put all the assets that we receive, and then PESA's duty is to take those assets and move them around to actionable items to officers that can make decisions quickly, get the information they need, make important input pieces that they have to rely on. And it's all based on preset authorization, so that, for example, the guys at the top there might be unclassified, the guys in the middle might be classified, and the very guys at the back might be top secret, or what have you. But this is very traditional, and this is what we've been working on for the past 12 years. So we know these environments fairly well. Now, that's also true of Arista, right? They've been in a lot of these environments. But let's talk just a little bit about, these traditional environments and what caused us to move on and to create a new system, right?
So wait, we're going to talk about the old and busted?
Yeah, the old and busted. Yeah. So here we are. The scale is extremely limited. Once we have a matrix in place, we have so many inputs and so many outputs. And when you exceed that, there isn't any place to put extra cables. We have to start all over again. This is extremely cumbersome. So we have to guess big, right? So most of these installations had to put in enormous router sizes that they'll never use and put in cabling that is extremely inflexible. Formats are limited. Robert, you remember the days when we were trying to move around 4K and in the early parts, and then as we had to integrate them back and forth to 1080p or 1080i or 720p, this became a real problem. And security, there wasn't any.
It's funny because you look at the cables and you think about inflexible. There it is right there in front of you, Yeah. And I remember, and this is how far back I go, is we actually stretched the cables out. We figured out what the longest length was, and that was the timing. And then we coiled other cables up because it was very, very specific on the timing. And then you don't want to move anything around after you put it in, because if it's on port 1, it's going to stay on port 1. If it's on port 12, it's going to stay on port 12. But if you needed to add something, very challenging. You have to rethink the whole thing, and also keep yourself, I have X number, this is a, 128 by 128, for example. Do I need more? And how do you do that? How do you add more? Then you have to do tie lines and all kinds of other complex things.
Well, and just to keep track of it, I like the little piece of paper tagged onto the top of the racks. I can't tell you how many times I've been in a rack room and go, hey, where's there it is. And it's tagged up on one of the racks with with masking tape, just like you see there. Okay, so what we want to navigate to is an IP matrix, and with it there's some challenges there. One of the upsides of this is it's nearly limitless in terms of the number of sources and destinations. Now that's different from old busted, right? We had a very fixed limitation in terms of the density of the matrix that went into these installations. So, for example, it might be 228 by 228. When you hit the 229th source, you were done. In the IP side of things, it's simply adding extra switches. And this is the real attraction for, designers like ourselves, where we were trying to move video, audio, USB, and other very interdependent signals around a SCIF. These are accommodated easily in an IP matrix. Now, the key piece of this, as we grow it, right, is the software-defined networking. And that means we've got to have a very tight integration between source and destination matrix and the switch fabric matrix. so that if I have a source, for example, on switch number 3, and I want to send it to a destination on switch number 7, I've got to go through the spine at switch number 5, right? So somebody's got to keep track of, how to manage those payloads from uplink port to uplink port and back again, so that we don't oversubscribe those ports. And the method to do that is also complicated, because in these DoD environments, and a lot of our intelligence communities as well, these require very tight security. So with it becomes the mandate of FIPS. FIPS is really kind of the key crypto piece that DoD requires, the Department of Defense Information Network. They have a lab at Fort Huachuca that's called the Joint Interoperability Test Center. I might add that Arista is used as the backbone for that testing center as well. But they mandated that all IP communications has to be FIPS 140-2 certified. And so the challenge for us is to start there, right? You can't end at the very end and just throw this thing at the end of it. It has to actually start at the beginning, so that every encrypted flow has to have this FIPS encryption. That's not only for essence signals like video and audio and USB, but also communication signals between our controller and the PESA switch, for example. And the other pieces might be touch panels, so that I want to dictate which source and which destination I want to connect to. Those require FIPS communications. So all of that is managed with keys and certs and trusts and all the additional pieces and parts of that. Now, there are other certifications involved here, such as the APL, the Approved Products List from the DoD side. There's also common criteria. Common criteria is a certification effort used by a lot of intelligence communities, but also outsiders that want to be assured that their communications is in fact properly encrypted and properly secured. So here it is, right? This changes. This is the new cool, right? We have a FIPS IP SCIF. Wow. We move all the assets into the secure server room, and now we can dole them out to the officers that are on the floor, right? I can't tell you how many times I've heard from officers that said, geez, it would really be nice if we could change our missions, because they change, right? It's the speed of the mission. This is what Rob mentioned at the very beginning of the slide deck, right? So that we might, for example, have all classified in here for a particular mission. And we have to clear the whole room out. We have to move all the top secret guys in and move all the classified guys out. Those guys have to go to some other SCIF or whatever. And this becomes a very fixed and unmovable SCIF. In other words, the assignments are hard. The cabling that goes to each of these desks is hard, and all of the assets that they gather is hard. If we had a flexible environment like this and we could secure those flows to each workstation as we dictated, this makes this a very interesting SCIF, because we could mix things. We could have all the top secret guys at the back. We could move them around to the liking of the officer in charge of the mission. We can get information quickly. And that's really the point of all of this. Now, with that, we actually have a method to be able to create a classification. For example, we know that signal XYZ is a classified signal. We also know that signal LMNOP, that signal is unclassified. And so we can keep those security flows even, so that each box is able to properly authorize for its classification. So the officer sitting at the seat, he's cleared for classified use, so he can see anything below his class, but he's not cleared for anything above his class. You need signal classifications to make sure that you're properly getting those signals to them, and that's based on authorizations. And
Hey, Scott.
Wait, hang on.
Go ahead, interrupt me. I'm so.
Yeah, quick question, Scott. Go back to the previous slide.
Yep.
Please give an explanation. What's the red carpet there, or the red cloud signify?
Yeah, so that's all the security around a particular rack room. These are very common in SCIFs. The rack room has very secured clearances. Only certain officers can get in. to that room, or certain agents, I should say, depending on the agency we're working with. But these rooms are guarded, right? These aren't just open rack rooms. And so we want to move the PCs that the officers use back into this rack room so that we can dole those assets out onto the floor, and there's no gee, the PC doesn't work and we've got to move it out, we got to move another one in, and all this kind of thing that I hear constantly from guys that are running these floors.
You know, it's also interesting about this is the nimbleness factor of this is you can change this as needed.
Right.
There's no moving of cables anymore, and it's secured, meaning that if I'm a security officer and I need to have certain missions going on, and you're another security officer, you have control of your video endpoints, and I have control over my video endpoints. And if we need to change the mission at any point in time, we can say, okay, everybody shift left, right? And then add people as needed. And this is just in one skiff. I mean, you know, there are questions about multi-skiff I think we're going to get into too.
Yeah, exactly. So, you know, how do we do this, right? We elected to put this new controller onto a Kubernetes cluster, right? That means I can use containers and microservices, and these can be existent in current architectures that are already deployed, right? We've already heard the press about Azure being used by the Pentagon. Others are using their own, and of course the military has their own cloud infrastructures. But the idea is that we can place our control software into these kinds of environments, and that allows for, you know, the intermix of domain classes, so class, unclass, secret, top secret, and the ability to traverse these things at a moment's notice, so that I could have a secure data center that's controlling the particular skiff, or it could be a persistent connection where it's actually located in the rack room that I just showed you, or it could be located in somewhere in the military network where we have a backup. And this never happened before. The idea, though, I mean, the whole premise of this concept is FIPS encryption from source to glass. Now, as a result of this, we've encountered that we've never seen this out there in the wild, so to speak. And we've applied for some patents on some of these ideas. They're very groundbreaking. So again, Robert alluded to this earlier. If we want to connect a skiff to a skiff, right now it's really painful. My guys tell me that they have to end up putting in huge patch bays and connect one skiff to another, or parts of the skiff, right? So it's not the entire skiff, but let's say I have an officer that needs to be moved into a skiff that needs his information and his particular talent set, and I need to connect him over to the guy that's working on this particular mission. That would be very, very difficult in a current baseband environment. But in an IP environment, we can shift that in a moment's notice. Again, the speed of the mission. Can we get the assets we need critically to the floor that needs to make these decisions? It's an interesting concept, moving pieces and parts around, because if I can do this within a construct of, say, a base, and I have several skiffs, and I want to move from skiff to skiff, I could actually move from base to base. So this concept is extended, and that's actually the Navy that has asked about, we want to know a little more about what you could do virtually. Could we distribute that C2, one from a central location and one to a distributed location? This becomes extremely, extremely important for fast, critical decisions. Now, the crux of this, right, is I need someone with network expertise, right? That's got to be Arista. And Arista helps us transform this. Why? Because they use open standards. They're very flexible to work with. They know video. That's really important for us. And they can deliver performance and reliability for the kinds of work that we expect in these environments.
Yeah, that's right. And so we've been doing this for a while, and Arista's been doing security for quite a while. We've been starting off with not only the Fed environment, but also a financial environment. And we call it no packet left behind. And we'll get a little bit more into that, which is to have something that's a guaranteed platform for you to build your solution sets on top of. And if you can go to the next slide, but it also has to be not really good hardware. It has to be really great software. And we have this thing called CVEs, common vulnerabilities and exposures. It's basically a database of all the exposures that are known out in the wild. Whether there's an exploit or not, this has to be known. And if you look at the number of CVEs that Arista has versus everybody else, it's very, very low. And in fact, if we put up the bar chart, we'll see if we can find the Arista. Oh yeah, it's way down. It's a little tiny blue slice that you see right there. This is all public information, by the way. And so other people might say, is it a bug or a feature? Hey, you get a feature with your bug, and not to go to the Men in Black type of scenario, but what we're trying to do is build something so you don't have to think about it. You shouldn't have to expect to focus on your infrastructure. You want to focus on the mission, as Rob said at the beginning. This is about the mission. This is not about the network. It's not about the infrastructure. This is about enablement and having to not worry or just take that worry away that you've got a secure environment. Again, it's all about the security end to end and the vulnerabilities taken out of the situation. So that's what we're getting towards. And I'm going to pitch this over to Judson, my friend Judson over here, who lives and breathes this stuff, my friend. So why
Hey,
don't
Rob.
you tell us about where we're deployed?
Oh, yeah, sure. So, yeah, Arista is definitely has been in the federal community for quite a while. And a lot of the attributes that were just discussed fits very in line with some of our use cases that we've deployed. We've delivered solutions from the client to the cloud when it comes to infrastructure. And again, being specialized with delivering video as part of our heritage has bode well within this particular solution. But as far as use cases, we support various activities within the IC, DoD, and civilian. So definitely a proven commodity over time. And we've really predicated that based on our current certifications. So as you look at the DOD and APL from a DoD perspective, the goal here is to provide you choice. So we actually have 8 different product families that reside within the DOD and APL today. So we have a single operating system, set a standard way of doing things from a software perspective, but now we're giving you hardware choice based on a set of attributes that you need for your particular environment or use case. So again, prime and ready to go to support the community.
You mentioned that again. It's like, and if you go back to that, there's a bunch of SKUs on the product family here, and it's one operating system, one binary. And what that really means for you is you don't have to figure out what version of code to work on which box. You figure it out once. We do that API integration once. It's like having different keys to your front door and back door and side door, or how many doors you have. I know, for example, Rob's got this 300 square foot apartment, but he's got this 10,000 foot, house that he lives in, and he's got 15 doors on it. Imagine if he had 15, he would look like a security guy walking around with different keys. So you got one API, one integration to everything. And so you test it once, you validate it once, and then you figure out, do I need PoE? Do I need 400 gig? Do I need a chassis-based system? That's what we want you to think about, is more about how you deploy it and give options to it. Right, Judson? I don't know if you agree with that.
Exactly. Spot on, Rob. It's all about the attributes. What are the attributes that you're looking for that steers you in a direction, but again, is the software that makes it pop and makes it shine. And that fits in these use cases that we're talking about.
Absolutely. And this partnership, this cohesiveness between our two companies started from a long time ago. Robert and I actually worked on a interop several years ago, about killed both of us. I still got coffee burns. I swear to God. The point of the slide here is that Arista is very familiar with high-speed performance with respect to video, and it's video that is a little different than, say, a business network, for example. And I'm not poo-pooing business networks, because they can have literally 10,000 endpoints or whatever. But the needs are different, and we work together from these very beginnings as companies and knowledge sources to understand that our flows are a little different looking than, say, the average. For example, the use at NASDAQ is completely different than video, and it's completely different from other use cases as well. Robert, maybe you can get into the details of how different you see video and how the EOS falls into this.
It's interesting. And in fact, if you go to the next slide, and I talked about no packet left behind, you have to start off with this thing. And some of this is a little bit technical. It's called a non-blocking network, and not all switches are created equal. Arista specializes in literally making sure that you get from point A to point B. But you also have to have, and you alluded to this, Scott, earlier, which we'll get into a little bit more, which is the SDN, the software-defined networking. And a question came into the chat window here, which is, do I need to have 3 CCIEs on staff to make this work? No. It's about the programmability. We want to make sure that the switch is programmable, it's accessible, and you get the information in and out. You're telling it what to do, but you're also getting that real-time statistics. So talk about situational awareness. You know at every millisecond, every nanosecond what's going on. You get that information out so you know, hey, am I having an issue on a transceiver? Am I having an issue on a flow? Where is this particular connection? And you get that in real time. So, and then there's no time like the present. I know this is very cliche, but that's the way that we work. And you want to know what happened also at like 2 o'clock last night, what was going on with the network. You can get all that information through our cloud vision. So it's information in, information out, and scalability to this, and security.
Yeah, absolutely. The quote I like from Ken Duda, who's one of the founding members of Arista. They asked him, you're using a regular off-the-shelf Linux to create EOS, and he said, yeah, I know. He said, well, aren't you afraid of people doing something with it that you don't want them to? He goes, God, I'm betting that somebody's going to do some interesting things with this. And he's right. This is the power of EOS, right? This is why you don't need a whole bunch of engineers and expertise at this, right? You just simply want it to work, and you simply need the packet to arrive where it needs to go. So one of the things that we found compelling nearly from the very beginning is the ability to put in a crypto module so that all communications within the SCIF can be protected, so that when we're making a call to the switch, we can do so using our FIPS module. And that brings us to how we're actually doing the SDN parts, right? The software-defined networking. Yeah, go ahead.
Let me interrupt. I think a question came in that's probably relevant to what we're talking about with certification. The question was, what certifications are required in order to integrate these systems?
Yeah, so that's a great question. It depends on the agency. It depends on the government branch, if you will. So DoD, for example, is different than intelligence. So intelligence might have the three-letter agencies we're familiar with, the FBI, CIA, whatever. Those agencies do their own thing. Some others rely on common criteria. Others rely on the DoD. So it depends on the agency and the certs required. But what we found over at least the extensibility of how we're pulling together the IP flows with respect to audio, video, and USB, those critical essence signals in our system, we found that the FIPS piece is really the core piece of the crypto, so that we can ensure security from point A to point B. This is kind of the root of where we're from. And this is kind of the NIST enclave, where they have all the FIPS standards for various and sundry pieces and parts. So if you wander into the NIST site, you can see all those certs. And various agencies insist on certain parts of NIST to be deployed in particular environments. So not all of them apply to video and audio. We are a closed network, so we don't just spill this stuff up into the open network. This is kind of unique to the SCIF proper. Military networks are isolated in one half, and our network is kind of closed, like it did with the old and busted, if you will. We just have a lot more flexibility in moving that guy around. So now the SDN, thinking of extensibility, right? What has to happen is the switch can't be clogged down between switches, right? So in other words, if I have uplink ports on one switch and I have uplink ports on another, I can't exceed the bandwidth. So something has to come in and manage those payloads on the uplink ports to and from a particular spine, for example, or a redundant spine, or however you've architected this. But the point is, if I have a flow that's on from one of my Secura nodes, you see on the far right, I have to go back through encryption, ask my controller, hey, I want this other destination or other source on my destination box. And we've cleared it for use. And we're telling the network that, hey, we're on switch 3, guide needs it on switch 12. We need to move that. So they have to be familiar with our matrix so that they know what flows are positioned on which switch. So there's a very tight integration. And what we discovered was this is very, very easy to do with the EOS and the Arista fabric.
Yeah, it's interesting too, because then you can find out where the congestion is or predict where the congestion is. And it's about getting from point A to point B. We had the distributed architecture in one of the prior slides. And so it's more like instead of going from a GPS, you're going to Waze. You know where your traffic is going. But the other interesting thing is not only is it secure from an API perspective as it touches back and forth, as it's told what to do, we've basically taken out the ability to do anything with multicast itself. There's no dynamic joins in here. You have to go through a process in order for that flow to go from point A to point B securely and then get decrypted. So it's not like somebody can go in and just say, hey, arbitrarily, I want to try and try to hack something.
Yeah, yeah. The whole point of a secure system is to keep the bad guys out, whether they're inside or they're outside, right? So they have to have the proper keys. They have to have the proper node box to have this. There's a lot of checks and balances against this, but at the root of it is the crypto that we move to and from all of these pieces, and they're very, very, very tightly integrated.
Scott, another question that's timed, I believe timed around, it just came in, is that you said scaling is simple, just add another switch, but the question is, do I have to worry about grooming, oversubscribing, balancing, backplane capabilities, etc.?
Yeah, that's not a problem. Now that we have an SDN controller to know which ports we're going to connect to, these are tightly integrated to the ASICs that are in the Arista fabric, so that when we go in, we actually know from the ASIC level how this is actually connected, right? So, yeah, that takes the sting out of adding another switch, right? You add another switch. My controller knows, oh, we're adding a 7050 SX3. -32. I know what he's got there. Yeah, his uplink ports, which ones are those? Oh, yeah, they're ports number 35, 36, 37, and 38. No problem. I know what those bandwidths are. I know what we've got to have there, and I'm going to balance those so that I don't have any one particular uplink port that's, for example, really overloaded and the other three are light. I'm going to balance those 4 uplink ports evenly so that I have a very even set of traffic pieces and parts. But for the user, we simply add a switch. That's how easy this is, right? So when we get into the details of it, where we're really driving here, and Robert, you touched on it earlier, you just don't get into the switch and make a rogue join from the IGMP core, right? This is all deterministic, right? It has to be signed, sealed, and delivered from our controller to say, yep, that guy's cleared to connect. And we know, as this SDN chunk of this, where the actual endpoints are located, right? So that helps us with the multicast and unicast routing. This is scalable. This is completely balanced. We have quality of service flows, and we have some management tools that we can add to this, and automation, right? We can actually create things on the fly so that if we have to spin up a whole other skiff, we can do this in really short order. Right? If we have an emergency and it's speed of the mission and we got to do it now with this kind of fabric, it's not a problem. This would slow people down for days, maybe weeks. And we don't have that issue, so that we can scale it up from, I don't know, 200, 300 flows to thousands of flows, right? Our controller has been tested against 1 million flows. So, this is the kind of flexibility and the kind of tight integration that we've made with Arista. This happens securely, right? So what happens in the big picture is we can take assets out of a secure room and move them to individual components. Very interesting idea. Now, it does require some different changes in the codecs that we're going to use, at least with respecting the video. But the fabric that connects them, that's the part that's adaptable, right? We have the reality of bandwidth limited networks, right? So we have to create some codecs on our end to move those flows to secure skiffs or isolated skiffs, or maybe a kind of the way to think about these might be safe rooms, rooms that agencies and Department of Defense is authorized. Okay, we're going to create a special link here. It isn't 100 gig in payload. We can only manage 10 megabits or whatever that might be. These are the kinds of pieces that we can connect together within the confines of a military network or an agency network or a government network or a communications network for hospitals and other pieces and parts of this.
And multiple missions at the same time, and that's an interesting thing too. Whereas if I'm in control of one mission and you're controlling another one, then we are only in control of those particular endpoints. And if we decide to move things around and you want to take over something because you need that particular seat or whatever it is, then we can flip that over to you. And this is all happening because of the IP and the security end to end. Again, we have the certificates at the end that we know where it's going to. It's a verified endpoint, and you can only add verified endpoints.
Right, exactly. So to kind of boil this down, really, it's nothing's more important than the mission, right? That's what we stated at the very beginning. We need a secure method of moving critical assets from point A to point B at a moment's notice. It needs to be clear, it needs to be accurate, and we need to give the people on the floor the situational awareness so they can do their job. It's as good as being there. That's what we were after, right? This is how these rooms work now. We just want to extend them so that they're more flexible and they're speedier and they're more actionable. That's the whole point of what we built around this thing. And that really gives us the ability to do things like this, right? If we have a Kubernetes cluster that's already in the Department of Defense or in an intelligence agency, and we have a SCIF and we need to move that information quickly to another SCIF that's located in another part of the world, we need to do that. We need to be able to do it, and we need to do it now, right? That's also true of pieces and parts that generals, commanders need to know about at a moment's notice. They want to know it, and they want to know it now. It's
So
the
it's
new
distributed
hotness.
C4I, I think is another way to put it, right?
Yeah. Okay, so that brings us here. Rob?
Yeah, fantastic. Well, good. We've had a lot of questions come in. You can see our distinguished panel up there, less me, just the moderator. But we've had a lot of great questions come in. So let's just hit some of one that has come in a couple of variety of different ways. The question is, does the secure aspect of this transport introduce heavy latency? Latency, obviously, we know is always a big factor. So how about when you introduce heavy latency?
Yeah, I purposely didn't get into all the specifics of the nodes because sometimes that isn't a common question. But we know that from using our real-time systems in the baseband world, we knew that one of the goals would be to be able to take enormous flows, 12 gig per second flows of video, for example, and compress them such that I don't end up with delay or any or worse any loss in the video. Right? We wanted to use a lossless codec. We wanted to use roughly a gig payload, and we needed it low latency. So I'm happy to report that our latency end to end is less than 4 milliseconds. Now, for most applications in video, the human perception is about 70 milliseconds-ish, and you won't notice which one's live and which one's Memorex, if you remember those old days. The old busted days.
Oh, yeah. Oh, yeah. Okay, good. Another question as well, and this is an interesting question. It says, my SCIF is already secured, so why do I need added security in my secured SCIF?
That's a great question. You know, this one comes up time and time again, you know. And Judson, you can chime in here too. If you want to get it pushed through Doden, if you want an APL, you've got to prove what FIPS modules you're going to use and how your flows are protected, et cetera, et cetera. So while your SCIF might be secure, and you are completely happy with the way things are, for me as a vendor to get it through the joint interoperability test command, that thing has to have FIPS communications to and from. And they don't care whether it's a video flow or whether it's a communications flow or any kind of flow. If it's IP, it's got to have encryption. So while you may not think you need it, as a vendor, I have to have it or I won't be on the APL. And it's for good reason, right? The guys are looking for making sure that your products have been tested and they're going to be used in the manner that Department of Defense expects.
You're spot on,
You've
Scott.
got some insight on that, Judson.
Yeah, just to add to that, it's again, if you think about a SCIF, it's layers of security. There's physical security, there's also network security, and there's also visual security, etc. So they are mutually exclusive and mutually inclusive depending on the conversation. So again, from a vendor's perspective, ensuring that from a networking or a service delivery perspective, that we check the appropriate wickets to deliver those secure comms in an appropriate way, whether they be in a physical secure facility or not.
One other aspect is insider threat. With the old system, it's merely scrambled, they're not encrypted. So insider threat is a real issue for things inside a SCIF.
Great point.
Absolutely. Absolutely. Yeah, another question that's come in more on the Arista side. You mentioned Arista is involved in the U.S. defense market, but what about the European or NATO markets?
That's a great question. They are. They have other certifications, and there are a ton of them out there. Most of the ones that are in the NATO groups rely on common criteria. I know, Judson, you have a number of your switches verified and,
Yeah.
and done. I'm not sure. I'm pretty sure you did those under protection profiles, but
That is correct.
maybe you can elaborate on that, since that's really kind of a
Let
specialty.
me take that one, Scott. So what we have right now is we got wide deployments in all branches of service of the Department of Defense, civilian agencies, and predominantly the intelligence community. Those solutions have propagated throughout our coalition partners, NATO, foreign military sales. And Arista as a whole has got a global sales team that's actually supporting public sector market in Europe, in Asia, South America, et cetera. So we're already deployed in core areas of competence of Arista as a company today. The certification leverage, it does change when you go into Europe versus the US. But what you're going to find is that there are acceptable alternatives, or if, for instance, if your common criterion FIPS in the United States, it'll replace some of the EAL type of requirements that have come out specifically for Europe. They're acceptable alternative. So we're in good stead across the globe.
A couple more questions that have come in. One is within the network deployment side, will this have any issues with distributing NDI?
Yeah, I'll take that one. So you want to think about, again, what the mission, pardon the overuse of the term here, of the network itself. Could you use the same network for that as well? Yes, but NDI is not necessarily secure. SMPTE 2110, we're working on security aspects of it. There is no level of encryption just yet that's we've agreed upon. And as well as thinking about that endpoint itself, you want to put a key out there. How do you actually put a key out there? So while yes, you could use both simultaneously, what you're going to lose is the effectiveness of keeping it all clean. And I attribute it to some things we do, like, for example, in the PCI industry and security industries and things like that, is now you've just opened it up for an audit, right? Did somebody put something on the network that they shouldn't have, right? Should they be connecting to the network to begin with all these other things? So yes, it can, but it's really a question of, should you do that?
Yeah, that's a great, I was going to add to that in that these are open standards. I wouldn't say maybe necessarily NDI is an open standard, but certainly 2110 is a standard, having worked on the committee, and Robert has as well. But these are intended to be open standards so that you can interoperate together, so the signals remain, open. But that's also a liability. I remember participating, or at least listening to a panel discussion at one of the conferences, and one of the commanders in charge of the space parts, and specifically satellite communications, is they launched a satellite 40 years ago, 50 years ago, and maybe even longer, and some maybe say even fairly newer. They never really gave much credence to the idea that they needed to keep this guy defensible. In other words, they didn't need the ability to do that. And then, of course, now they do. But it's a little late. It's kind of like you can't add security at the end of this. So in a roundabout way, it becomes kind of a liability, so that if it is open, anybody can get it, including the bad guys, right? So you have to have a means of saying, okay, well, this is important signal, right? I want to encrypt it, and I want to make sure that nobody else can see it. So with that said, they kind of duke it out, if you will, between open standards that allow everything open and closed, where we want to make sure we have control over what's being transported across the network. Mm-hmm. It's interesting times we live in.
Rob, any other questions come in?
Yeah, there's a couple more questions. One question is, and I think we covered this, but it came up again. How is the encryption handled? Is it bulk or individual? And I think you already spoke to that, Scott, but maybe just a refresher.
You broke up a little bit there, Rob, so I couldn't understand what your question was.
Okay, yeah, the question, yeah, how is encryption handled, bulk or individual?
Oh, it's handled individually. And this goes to the way we actually treat the flows, right? So video and audio are not together, and video and audio and USB are not together. They're all individual flows, and each of those encrypted flows is encrypted separately. So we don't just do a straight roundhouse bulk encryption across the whole flow or all flows going through a particular setup. We actually encrypt each individual stream. Now, what that allows us to do is to connect USB assets like mouse and keyboard, for example. Sounds benign, but you wouldn't want somebody to grab hold of an asset that doesn't have the authority to do that, right? So that's a real key feature and an absolute necessity to be able to say, okay, well, this classified guy has access to this resource. He's cleared. He can now move his keyboard independently without affecting his video or his audio. In other words, he's got his screens exactly the way he wants them. He's hearing the audio, he's seeing the video, and now he just wants to move his mouse and keyboard. With separate flows and separate encryption and separate authorizations, we can pull this off, right? So that he has a lot of flexibility at the workstation so that he doesn't have a whole bunch of little widgets or stuff that you can change the keyboard with a little A, B, C, D switch or, some other kind of converters and all these little extra widgets and parts. And we've taken all that out so that it's a lot easier to manage. And we can keep the security intact, right? We're delivering it from the source all the way to the end seat that we need it to be.
I think I got one more question here. It says, what about KVM? We have small spaces. Does this add complication to my desktop?
I just got into that. Yeah. So the idea or one of the complaints that we hear time and time again is, geez, I got all this stuff on my desk. I mean, I got cables here, got cables there. I got a box for this, a box for that. I got all this stuff, and now we can deliver all these signals in a standard fiber optic cable. I mean, this has been something that the IT community has enjoyed for decades. We're just kind of a little late to the party. So yeah. The idea that we can bring in all of these resources in one bulk topology using, Ethernet and secured Ethernet lends itself to reducing cables, right? So the idea was that we could come up with a really nice, clean interface, a nice, clean desktop, one mouse, one keyboard, move it around as you wish, have a CAC reader, for example, have a token reader, or whatever that seat might require. But the idea of being able to deliver video and audio and have everything at the commander's desktop and fingertips was what we were after. And these are the problems that this particular environment solves.
Fantastic. Okay, we got one more question since we're coming up to the top of the hour. And the question is, you've been talking about defense a lot, but is this adaptable to enterprise businesses?
Yeah, it is. That's a very good question. And so we talk about media entertainment too, and I want to talk about that a little bit too as well, is you could take what's happening on set and then have a producer, director, whatever it is, remote, take a look at that, or some type of secure communication. So that's a guarantee type of function. Okay. We were talking about, doing this also virtually, if you will. So it's more distributed, but you only have access to that video while you have access to it, while I grant it. But you can also think about what's happening from a COVID perspective. And there's actually, I think it was a pile-on question to this, is you can think about what's happening with the mayors that are going on, or the senators that are working remotely, or some other things. You can talk about secure communication between the CXOs, right? You don't want somebody else just to join a video call and lurk in. So it's security in mind. Now, one could say, well, I don't need all the security. I just want to do all this stuff that, the PESA team has done and turn all that off. Well, that, sure, you could definitely do that. If you want to turn off encryption and just have the endpoints out there, absolutely, and have that guaranteed functionality, absolutely. We're thinking about the worst case scenario and what, we focus in on, which is security, defense in depth, if you will. But sure, this could be used in a multitude of ways. And again, it's just a small set-top box with a remote KVM, so there's very little on your desktop. And in today's distributed environment, getting stuff done quickly, whether it's the mission or whatever you're trying to achieve from an enterprise, getting it done quickly again is the key point. And 4K, it's the ability to get high resolution. It's not Zoom level and video. This is real, true 4K video, compressed and delivered to you in real time. Sorry, a little diatribe there. I guess the coffee's kicking in.
No
worries.
Absolutely. Yeah, absolutely. A couple more enterprise solutions. Again, and we'll close with this that we're exploring and actually engage with are markets that you would probably never think of: cruise ships that may need secured classification levels, Airports, we've talked a lot about airports. We've all been through airports. You see just a slew of monitors throughout airports and running a very unsecured network. Sports stadiums. So again, the list goes on and on. Federal, state government. So yes, there is many markets outside of the federal government that are applicable to the joint solutions that we're talking about. So, and the last question was, is in the encryption level AES 256? The answer is yes. It is AES 256 encryption. Is that correct, Mr. Barella?
Yes, it is. And there's
Okay.
a whole bunch of other stuff that go along with it, the SHAs and the
Fantastic.
RSA
Well, again,
keys and the certs and the,
yeah, we very much appreciate it. And again, on behalf of PESA and Arista, want to thank each of you for your interest in today's event. And we invite everybody to visit the websites of both Arista and PESA for additional information or to reach out to us directly. You have the email addresses or the website. You can just email sales at each one of the respective companies. And again, if there's any questions that we did not get to, we'll look forward to answering those individually. And again, be looking forward to the follow-up email that will have the link to this live presentation. So again, we very much appreciate your time to join us today. Very much appreciated. Thank you. We hope it was informative, and have a great Merry Christmas and a great holiday season to all. Thank you very much.
Take care.
Bye-bye.